This video is for lesson 16-2, proving a quadrilateral is a rectangle. Learning goals are to develop criteria for showing that a quadrilateral is a rectangle and then to use those criteria to prove that things are rectangles. So first of all, let's review what a rectangle is. Number one, a rectangle is a parallelogram with, that is, 4 right angles. You wrote this definition in a previous lesson. A rectangle is a parallelogram with 4 right angles. Next, let's complete a theorem about this. If a parallelogram has 1 right angle, then it has blank right angles, and it is a blank. Let's fill these in. If we know that a parallelogram has 1 90-degree angle, then that is enough information to know that all of them are right angles. And so right in here, we're going to fill in 4. And we would know that this is a rectangle. This theorem is a criteria to determine if a 4-sided shape is a rectangle. We would look to see if we know it's a parallelogram and if we know it has at least 1 right angle. And if it qualifies, then we know for sure that it's a rectangle. Let's look at another theorem. If a quadrilateral is equiangular, meaning if it has equal angles, then it is a rectangle. This theorem gives us another way to determine if a 4-sided shape is a rectangle. We look at the angles, and if all 4 angles are equal, then they must be 90-degree angles, and we would know for sure it's a rectangle. Let's create yet another theorem. Here's a drawing of a rectangle OKAY. And then we have segments from corner to opposite corner. These are called diagonals. So let's create a theorem involving the diagonals. Right down here, let's write that. If the diagonals of a parallelogram are blank, then the parallelogram is a, well, what does this drawing suggest to us about the diagonals? They look the same length in there. So let's fill in the word congruent in this blank. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So here is yet another criteria we can use to determine if a 4-sided shape is a rectangle. First, we would look to see, is it a parallelogram? And then draw the diagonals. And if those diagonals are congruent to each other, then we know for sure that it is a rectangle. Here's an example problem like those in today's assignment. Given quadrilateral ABCD has coordinates A, B, C, and D at these values, can we show that the quadrilateral is a parallelogram? And then, if we find out it is a parallelogram, let's use one of our theorems to show that it's a rectangle. So the way that you would do this is to create a coordinate grid. Now, all of the numbers given to us are positive numbers, so we don't have to show the other quadrants. We really only need a quadrant 1 coordinate grid. 1, 2, 3, 4, 5, 6, 7. Our highest x coordinate right there is 7. That's as far as I'm going to make the marks on the x-axis. You can do more, but that would be a waste of time. Now on the y-axis, I'm going to count up to 5, because that 5 right there is the highest y value we have. We could show more, but that's a waste of time. Now 1, 0 is located here. 0, 3 is here. 6, 5 is right there. And 7, 2 is right there. Now let's connect those together and see what sort of a shape we've created. The first thing we're asked is this a parallelogram? Well, does it look like the opposite sides are parallel to each other? Yes, it does. This top looks parallel to the bottom, and the left side looks parallel to the right side. We could calculate slopes to tell that for sure. And then we're supposed to decide if that's a rectangle. We have different ways we can do that. We could draw in the diagonals. and then find those distances using the distance formula. If they're the same, then it is a rectangle. Or we could figure out one of the angles. If we can look at the slopes and find out that this and this are perpendicular, and that's a 90-degree corner right there, then that would be enough to show that this is a rectangle. Here's some check your understanding questions, so I'll pause the video for you to try these. Okay, here's the answers. Number 10, Jamie says that a quadrilateral with one right angle is a rectangle. Find a counterexample to show that Jamie is incorrect. So let's draw a quadrilateral. We're going to draw something with 4 sides, and let's give it one right angle. So here are 2 sides, and they connect, and they form a nice 90-degree corner right there. Now let's finish a quadrilateral, but when we get all done, make it not be a rectangle. If we do that, then this quadrilateral is a counterexample. It's a picture that shows that Jamie's argument is incorrect. So something like this kite shape here would be a counterexample for number 10. Now number 11, do the diagonals of a rectangle bisect each other? Well, let's see. Let's make ourselves a rectangle. And then draw the diagonals. Here's one of them. Here's the other one. Do they touch right in the middle of the figure? It looks like they do. So our answer is yes. And our justification is this picture. Well, that's it for today's lesson. We created a couple of theorems that we can use to determine if a 4-sided shape is a rectangle.